Okay, so have a little video. Hopefully it works like it did last time. And since I didn't have a lot of space on the paper, I just wrote some of the problems out. So I'm working on the bottom half. So it'll be these down here where you're having to choose if it's a single replacement or a double replacement before you begin. So first thing I'm going to do is choose what type of reaction I have. If I have a single replacement, a double replacement, or combustion. I do not have a carbon hydrogen group plus oxygen, so I can rule out combustion. So I'm just going to look and see how many elements I have in my compounds. So this is a 1 element right here, and here I have a compound with 2 different elements. So because I only have 1 element here, I know right away I'm going to have a single replacement reaction. So I'm just going to look at my rules, and I'm going to see what rule I'm going to be using. So for single replacement, basically I'm just trying to decide if I have a metal or a halogen to begin with. So zinc is in my transition metals block. So I know that I'm going to be looking at rules with metals, so I can rule out rule number 4. And this is just a compound. It's not water, it's not an acid. So I'm going to be looking at rule number 1. So this is single replacement number 1. So I know I can do this one of 2 ways. I can just go ahead and, since I know that my metal is going to replace a less active metal, I can look at my activity series. So I'm looking for zinc and silver. So let me get where there's no glare, maybe. Okay. So silver is at the bottom down here. And then my zinc is higher up. So I know my zinc is more reactive. So here my zinc is more reactive, so it is going to kick out my silver. On the test, I will tell you specifically, there's one section that you're going to have to choose if the reaction occurs based on using your activity series. For all the other reactions, you're just going to assume, I tell you that you will assume all reactions occur. So for the majority of the test, you will not have to use your activity series. You're just going to follow your rules for a single replacement. So zinc is going to kick out silver. Okay, so I can go ahead and write my equation. I'll work one that way. So since zinc kicked out my silver, I now have silver by itself. And my zinc is going to take the place of my silver. So I have zinc nitrate as my second compound. So I just have to write my formulas. So zinc is Zn plus silver is Ag, and I have my NO3 for nitrate. Silver has, where's my silver has a 1+ charge, and my nitrate has a 3- or a 1- charge. So those are going to cancel out. So like if I worked it up here, I'm making all kind of mistakes. 1-. So these are going to cross. Okay, I just have 1 of each, so I can write it just like this right here. Then after my arrow, I have silver by itself, so Ag plus zinc, nitrate. Okay, zinc has a 2+ oxidation number. So that means when I cross, I'm going to have a 2 subscript. It's important, don't forget your parentheses, okay, because my polyatomic ion acts like one thing, so I have 2 of these entire polyatomic ions. My last step is just to balance. So I have 2 nitrates over here. That means I need 2 nitrates over here. Remember, my coefficients can only go in front of my compounds. I cannot put a coefficient in the middle of a compound. So when I put my 2 here, it not only gives me 2 nitrates, it gives me 2 silvers. So that means on this side of the equation, I have to have 2 silvers. So that should be balanced. All right, next one, I have aluminum plus hydrogen chloride. So again, I'm going to determine if it's single replacement or double replacement. I have one element right here, so I know it is going to be single replacement and hydrogen chloride. So hydrogen chloride is the same thing as my HCl. So on our test, I'll either give you HCl or we'll call it hydrochloric acid. Aluminum is Al. Okay, so I'm going to look at my rule. And I just threw my paper. Okay. Sorry about that. So I'm going to look at my rule for single replacements, and I'm looking for one that's going to react with acid. So it tells me rule number 3, some metals will replace the H in an acid. So I'm going to produce a salt and a hydrogen gas. Okay, so I know my hydrogen gas is H2, it's diatomic. And my salt is just going to be a positive ion and a negative ion. So over here, I've used my hydrogen, so I'm left with aluminum and chlorine. Aluminum is positive, so it will go right here. Chlorine is negative, so it will go right here. I need to look at my oxidation numbers based on my periodic table. Al 3+, and chlorine is 1-. So after I do my criss-cross, my 3 is going to end up down there at the bottom. Okay, so these will not be part of your formula. They're just there to help you create your formula so you know what charges to crisscross. So I can write my words now. So I know I'm going to produce hydrogen gas because it tells me so, plus a salt. Here's my salt. I just have to name it. When I name ionic compounds, aluminum, I always name the first element, and then my second element always ends in "ide," aluminum chloride. With my equation, I just have to make sure it's balanced. So right now, I am not balanced. This one's going to be a little bit trickier, so I'm just going to write it out so you can kind of see how I do it. Okay, so I'm just counting out my atoms. Okay, so this is going to involve a couple steps, so just kind of follow along with me. And then if you can do it a quicker way in your head, like if you can recognize that it's going to happen first, you obviously don't have to work it out like this on the test. I'm just going to do it this way to help those who need help balancing. So I'm going to start with my chlorine, because me in particular, I always save, if I have hydrogens or oxygens, I usually try to save them for last, depending on the situation. And in this case, my aluminum is balanced. So I'm going to start with my chlorine. I can multiply this chlorine by 3 to get 3. That now gives me 3 hydrogens as well. Here I'm in a bit of a pickle. I have to use the least common multiple between 2 and 3 to get 6. So I'm going to multiply this hydrogen by 3 to get 6. Okay. Then when I come over here, I'm going to have to multiply this hydrogen by 2 to get 6. So this 2 is going to have to combine with this coefficient of 3 already there. This is one of those cases where you would multiply this 3 by 2 to get 6, or I can just look back at what I started with. I know I need 6 hydrogens on this side. I have a subscript of 1 here, so I know that I'm going to have to put a 6 right here. So I'm just gonna mark through that and put a 6. Okay, so I now have 6 hydrogens and 6 hydrogens. This, however, changes my chlorine. I have 6 total chlorines now. So I'm gonna have to come back to my chlorine on this side, multiply by 2. This 2 is gonna go in front of my chlorine compound to give me 6. Now I have 2 aluminum. This 1 I need to multiply by 2. So 2 goes up here. Okay, so that would be my final balanced equation. Moving on, so calcium plus aluminum nitrate, is it single or double replacement? I have one element right here, so that makes it a single replacement. Now I just have to determine my rule. I don't have an acid or water, and I know calcium is a metal, so my rule is going to be rule number 1. Sorry, focus. Okay, so I know that my calcium is just going to kick out my aluminum, so I can write my word equation first if I would like to, but you do not have to. So my aluminum is going to be by itself, and then I'm going to have a calcium nitrate. Okay, so all I did was just swap these two, basically. So for my equation, calcium is Ca, aluminum nitrate. Aluminum has a charge of 3+. When I swapped, I have aluminum plus calcium nitrate. Calcium has an oxidation number of 2+, so that's where my subscript of 2 comes, because I crisscrossed my oxidation number down. Okay, nitrate's oxidation number is 1, so I have my invisible 1 down there. Don't forget your parentheses here on these two. So there's my equation, and then all I have to do is balance. Okay, so really the only thing that's not balanced are my nitrates. So I have 3s and 2s, so I know that my least common multiple is going to be 6. What can I multiply 2 by to get 6 would be 3. Okay, on this side I have to multiply this by 2 to get 6. This also gives me 3 calciums. So put a 3 on my left side. Now I have 2 aluminums, so I put a 2 on my right side. Okay. If you had to determine if this reaction would actually take place, you would, it would take place, because all I would have to do is look on my activity series. This is my calcium. It is above my aluminum, so it is more reactive. So it is going to take the place of my aluminum element, ion. Okay, number 5. I don't know if I mentioned it. I skipped number 3 because oxalate is a polyatomic ion. We did not really talk about oxalate very much, so I will not give you something on the test that we have no experience using. So everything on the test is something that you've seen before. So the sulfates, nitrates, phosphates, hydroxides, those type of polyatomic ions that we've been using. Okay, so it wouldn't be anything unfamiliar on the test, because I'm not trying to trick you. Okay, so number 5. Is it single replacement, double replacement? I know it's not combustion because it's not a carbon-hydrogen group with oxygen. So I have potassium fluoride and I have lead nitrate. Both of these compounds have 2 different elements, so I know it's going to be a double replacement. So for double replacement, I need to look, I need to just basically figure out if I'm working with salts, acids, or bases. So I don't seem to have any type of acid, and I would have a base would be a hydroxide group. So Since I don't have any of that, I just have two salts. Salts are just created by combining positive and negative ions. That's all it is, okay? So all I'm gonna do is just swap my two positive cation ions. Okay, I cannot swap a positive and a negative because that would leave me with two positives together and two negatives together, and you cannot have an equation like that. It's always a positive and a negative. So once I swap these, I'm just gonna write my word equation first, okay? So my lead now comes over here with my fluoride. Lead, I have to keep my 2, that's just telling me my charge. Okay, so all I did was swap my lead and my potassium. Okay, so now I'm gonna write out my full formula. So potassium is just a K, fluoride is an F plus, lead is Pb, nitrate is NO3. This 2 is telling me lead's oxidation number is 2. Okay, nitrate's oxidation number is -1, so I have my invisible 1 down here. Then I'm just gonna write my next formulas, okay? So if you wanna work it this way where you've written your formulas first, I'm doing the same thing. This has 2 elements, so I know it's double replacement because this also has 2 elements. I'm just swapping my positive cations. So my potassium is gonna come over here with my nitrate, my lead is gonna come over here with my fluoride. Don't forget your lead. I've already told you it has a 2+ charge. Fluorine has a -1. So my invisible 1's down here, and my 2 from my lead crosses to be with my fluorine. Potassium and nitrate both have positive, both have 1's as their charge, +1 and -1. So they're just gonna be invisible 1's down here at the bottom. Am I balanced? Not quite. So over here I have 2 NO3s, over here I only have 1. So I need to put a 2 there. So now that gives me 2 NO3s. It also gives me 2 potassiums. So I'm gonna have to come over here, give myself 2 potassiums. Now this is giving me 2 fluorines. Do I have 2 fluorines over here? Yes, from this 2 right here. Okay, and then have 1 lead and 1 lead, so I am balanced. Double replacements, there's gonna be a question where I'm asking you to determine if there's a precipitate formed. So you're gonna look at your solubility rules. Okay, so let's look first. I have a fluoride, so I'm gonna look at my solubility rules and see if anything talks about fluorides. Okay, so no mention of fluorides, so I know that it's gonna be, it's soluble. Okay, there's nothing about any type of exceptions or anything like that. Okay, so it's gonna be soluble. So my other nitrate. Okay, let me look for nitrates. Do I have anything about nitrates on here? That would be rule number 2. Nitrates are soluble. Okay, so for this reaction, I would not have any type of precipitate formed. Okay, so because I don't have a precipitate formed, I'm not really gonna see any type of reaction. So even though we can work this out, we can assume this occurs, in the real world, there is actually no reaction. because they're gonna mix, but they're not actually, nothing is gonna happen. Kind of like in our lab, when you didn't see a color change, you didn't see a precipitate, okay, nothing really happened. They just mixed together to just create an aqueous solution with these two compounds in them. So they're not actually reacting in real life, but we're not really worried about that. We're just looking for a precipitate. All right, number 6. Calcium bromide. So I have 2 elements. Silver nitrate. I have 2 elements, so I know this is double replacement. And I think I forgot to, let's see, rule number. Do I have an acid or a base? No, I just have some salts. So this is just going to be rule number 3. Okay. So all that's going to happen is my calcium and my silver are going to swap places. So I'm going to end up with a silver bromide plus a calcium nitrate. Okay, so let me write out my chemical formulas. So calcium is Ca, bromide is Br. Calcium has a 2+ oxidation number, so I'm going to have a 2 down here next to my bromine. Silver has a 1+. Nitrate has a 1-, so it's just AgNO3. Silver bromide, they both have 1 charges. And then calcium nitrate. Calcium, again, has a 2+ oxidation number, so that 2 is going to come down here, and I have to have my parentheses because it's a polyatomic ion. Let me balance my equation. So I have 2 nitrates here. I need 2 nitrates here. This gives me 2 silvers, so I need to come over here, make 2 silvers. Now I have 2 bromines, and I have 2 bromines over here. Okay, and 1 calcium, 1 calcium. So this is balanced. Double replacement, okay, like I said on the test, it will give you a double replacement, and you will have to determine if a precipitate forms or if you can't see a reaction. So let's look at this first one. This is a bromide. So do we see anything about bromides on my solubility rules? Okay, number 3 says all bromides are soluble except lead, mercury, and silver. Well, what do you know here? I have a silver bromide. So it's not soluble. So that means I'm going to put my little S for solid, okay? I can go ahead and just double check myself. This is a nitrate, and according to rule number 2, all nitrates are soluble. So this nitrate would be soluble. Okay, so all I'm really looking for is this solid right here with my silver bromide. Okay. All right, last one, okay. So I have sodium chloride and I have potassium. So what type of reaction is this going to be? Potassium is 1 element, so it's going to be a single replacement. And my rule would be number 1 because I'm not looking at acids or water. So I need to look at my activity series, potassium and sodium. What is more reactive? So in this case, my potassium is more reactive than my sodium. So my reaction will occur. Okay, so my potassium is going to kick out my sodium. So I'm going to end up with potassium chloride plus sodium by itself. Okay, so I'm just going to write out my formula. So sodium chloride, NaCl, that's just like our table salt, plus potassium. Okay, remember my potassium is going to kick out my sodium, so I end up with potassium chloride plus sodium. Okay, and this is already balanced. All of these oxidation numbers are ones, so I didn't have anything extra to write.